Okay, so let's go and do some examples of rational functions. And what we want to do is we want to find the roots and the vertical asymptotes and the wholes. So first, in order to find the roots of a fraction, fractions are 0, right? A over b is 0 only when the top is 0, right? If the bottom is 0, it doesn't work, right? We can't have division by 0. So I think it's pretty easy to just prove that this is true. A is equal to 0 times b, which is 0. So A equals 0 is the time when you can find the function is going to be equal to 0. So what we're going to do is we're going to find these roots, the vertical asymptote, and the domains. So this x plus 4, x plus 2 over x squared minus 1 is 0 when the numerator, x plus 4, x plus 2, is equal to 0. So remember, we already have it in factored form. When it's factored, you just set each of the factors equal to 0. So x is equal to negative 4 here, and x is equal to minus 2. So the roots, so I'll write it up here, the roots are x equals negative 4 and x equals negative 2. The next thing that we want to find is vertical asymptotes and wholes. Okay. I call them removable discontinuities. It is a math term that comes up later on in calculus, so it might be useful to you to start using the actual math term instead of the English version of it. So to find vertical asymptotes, to find wholes, that happens when we have division by 0. So just like we set the top equal to 0, what we're going to do is we're going to set the bottom equal to 0. Well, if you have this part over here, right, we get x minus 1 times x plus 1. Why? Because it's a difference of squares. And then again, set each part equal to 0. So x is equal to 1, x is equal to minus 1. So we have negative 1 and 1 as the places where we have division by 0. But the question is, are they wholes or are they vertical asymptotes? So I'm going to go ahead and write this over here. So can you see that this causes a problem, right? We don't actually know which of the two they are. They're vertical asymptotes or wholes. So what we should have done in the very beginning was factor and simplify as soon as we can. So what I'm going to do is I'm going to rewrite this one as its factored form. Notice that we have no simplification now, right? There's nothing that cancels, which means both of these stay here, and they're both vertical asymptotes. Okay. We actually do not have any wholes because nothing was removed. Okay. One thing that you have to be very careful about is when you write vertical asymptotes, it has to be x equals, because vertical asymptotes are lines. Okay. So make sure you write them as x equals 1, x equals minus 1. So let's go ahead and do the other, now let's do the domain. So we have the vertical asymptotes, we have the wholes. The domain of this function is going to be negative infinity up to negative 1, negative 1 to 1, 1 to infinity. Now, if you can't see this using these numbers, let's draw it on a number line. And this one doesn't work, and that one doesn't work, right? We took them out. There's vertical asymptotes there. So this represents that section. This green part represents that section. And then the orange part represents that section. So the domain is everything except those 2 points. So let's go ahead and do the other two. So before we even start, right, let's factor everything so that we can see if we can simplify it or not. So the top part can be factored as, I would just assume it's probably 3 and 2, 3 and 2 as well. Okay. So this is 6x squared, this is 9x and 4x, add up to 13x and 3 times 2 is 6. Now factor out the bottom part, which is 2x, x, and then 4 and 3. So this gives you 8 plus 3, which is 11x, and then the 4 times 3 is 12x. And let's see if we can cancel something. Right? So these cancel, and as soon as you cancel something, if you are going to rewrite this, which is going to be 3x plus 2 divided by x plus 4, you have to write the restriction, which means you need to solve where you canceled equals 0. Okay? So x equals negative 3 over 2. That is the restriction. So you need to write here, x cannot be negative 3 over 2. So remember in our other example, right, that if we do not have that, the function is not the same. So using this now, we can find all the things that we did over here, which is the roots, the vertical asymptotes, and the holes. So I'm going to go ahead and write that over here. The roots happen when the top is equal to 0. So when 3x plus 2 is equal to 0. So let's solve this. 3x is equal to negative 2, and x is equal to negative 2 over 3. So the roots of this rational function is x equals negative 2 over 3. The vertical asymptote happens when the denominator is 0. But it happens when you have it simplified already. So we only need to worry about this one. And we already have the hole. The hole is the other one, the one that we saw from earlier. Okay. So one thing to be very careful about is whether or not you're saying x equals or x is not equal. Okay. So here, holes and vertical asymptotes, you're asking the question, what is the vertical asymptote? The vertical asymptote is negative 4. The hole is x equals negative 3 over 2. Here, what we're saying is in this function, you cannot have a value of negative 3 over 2. So be very careful about whether you're saying can equal or is the vertical asymptote versus the domain does not have this. Okay. And then lastly, domain. So the domain goes from negative infinity to negative 4, negative 4 to negative 3 over 2, and then negative 3 over 2 to infinity. And in order to do that, you have to know, again, that negative 4 is to the left of negative 3 over 2. All right, let's do the last one. 2m plus 3 divided by 2m squared plus 5m minus 3. So factor the bottom. Okay, it's going to be 2m minus 1 and m plus 3. And then ask, is there anything that we can cancel here? Right. So there's nothing to cancel. And we started off with something which is a rational with is not factored already. So in order to find the roots, 2m plus 3 is equal to 0, or m is equal to negative 3 over 2 by subtracting 3 divided by 2. And then the vertical asymptote is 2m minus 1 equals 0, or m plus 3 equals 0. So here m is equal to 1 over 2, and m is equal to negative 3. So we don't have to write the whole section, right? Because we already know that nothing will simplify. So that's the reason why you simplify first, so that you can determine whether or not there's holes or vertical asymptotes right away. And then lastly, the domain. The domain is given by, let's see, cannot be a half and cannot be -3. So negative infinity to -3, union -3 to a half, union a half to infinity. Right? All I did was took out the point half and -3, and that will give you the